Hello, Math 1. This video is on writing interval notation for both linear and compound inequalities. So basically, we talked about this entire chapter, what an inequality is. And when we break it down, it refers to a relationship that makes a non-equal comparison between two numbers. In terms that are probably easier to understand, it's basically a math sentence that uses greater than, less than, or not equal to. And remember, the greater than symbol is here, less than symbol, and then not equal to is here. Now we know the solutions to an inequality are the values of the variable that make the inequality true. Now we usually, represent the solution in one of two ways. One, we represent the solution graphically, right? But we can also use what we call interval notation. Okay. So interval notation is basically a way of writing subsets of the real number line. It's another way to describe the graph, right? Using what we call kind of like proper notation. So a couple of things about interval notation we need to know. One, if the graph of the inequality goes to the left forever and ever, what we do is we say that approaches negative infinity. If the graph goes to the right forever and ever, we say it approaches positive infinity. Now, we know that if we are less than or greater than, we know we use an open dot. Well, when we have less than or greater than with an inequality, we use a round parentheses to tell us that it's basically an open dot. It's not included in the solution set. If we have less than or equal to or greater than or equal to, we know that would be a closed dot on the graph, right? And anytime we have a closed dot, we use a square bracket, right? And that tells us that value is included in the subset, solution subset. Now, anytime we write interval notation, we write it from left to right. Okay, so let's take look at a couple of examples here. For the first couple of examples here, we're going to focus on interval notation for the graph. As you can see, for this graph, we have a closed dot on -6, and it's shaded to the left. Now, we know the inequality for this would be x is less than or equal to 6. That's the inequality. But how can we describe the graph? Well, if it goes to the left forever and ever, we write the interval notation from left to right. So where is it going where is it starting on the left? At negative infinity. And then where does it end on the right? It ends at 6. So when we write our interval notation, we know it's around parentheses, negative infinity, because that's where it's starting at on the left. And where does it end on the right? At 6. Since it's a closed dot, or it's equal to, we know we're going to use a square bracket. When we look at the second example here, we see an open dot on -1, and we are shaded to the right. If we were to write the inequality for this, it would be x is greater than -1. When we write interval notation, where does this graph start on the left? It starts at -1, and it goes right all the way to positive infinity. So again, when we write our interval notation, where are we starting on the left? We're starting at -1. Because it's an open dot, we're going to use a round parentheses. And where does it go all the way to the right? It goes to positive infinity, and it'd be a round parentheses. Now the next one, if I look here, there's a closed dot on 10, and it's shaded to the right. That tells me the inequality would be x is greater than or equal to 10. With this in mind, we know the interval notation starts at positive 10 on the left, and it goes all the way to positive infinity on the right. Since it's a closed dot or equal to, we know it's a square bracket 10, and it goes to infinity, and it's around parentheses. It's very important to know and understand that we write this from left to right. So we're going to go ahead and kind of take these inequalities, and we're going to write, right, the interval notation for the solutions to these inequalities. So when we when we write the interval notation, it's actually easier to kind of do it from the graph. So what I like to do is kind of just sketch the graph real quickly, right? So when I read this inequality, x is greater than 6, we know it would be since we're not equal to, it's an open dot on 6, and we would shade to the right. Now that quickly tells me that from left to right, my inequality starts at 6. Since it's not included, it's an open dot, it's around parentheses, 6, and it goes to infinity. The next one, if we were to sketch a graph, x is less than or equal to 0, we know it would be a closed dot on 0, and since we're less than 0, we would shade left. Well, we know this interval notation now starts at negative infinity on the left and stops at 0 on the right. Since it's a closed dot, we know we'd use a square bracket. So interval notation would be round parentheses, negative infinity, 0, square bracket. Next one, x is less than negative 4. We'd go to negative 4. We're less than it, so we'd shade left. So right away, x is less than negative 4. It tells me we start at negative infinity, and then we end at negative 4. Since it's an open dot and we're not equal to, it's around parentheses. Number 7, if we were to kind of switch this and say x is greater than or equal to 5, we know we'd have a closed dot on 5. Since we're greater than or equal to, we know we'd be to the right. Closed dot tells me square bracket 5, and it goes all the way to positive infinity. So interval notation, square bracket 5. Then it goes to positive infinity, round parentheses. And the last one, again, if we were to go ahead and kind of rewrite this as x is less than negative 3. And notice when I rewrite this, I look at the inequality here is eating the negative 3. When I rewrite it, I keep it eating negative 3. So we now read that as from the variable to the number, x is less than negative 3. So it would be an open dot on negative 3. Since we're less than, we would shade left. Where does this graph start on the left? At negative infinity. Where does it end on the right? Negative 3. So my interval notation, round parentheses, negative infinity to negative 3, open dot, tells me to use a round parentheses. So now when we talk about compound inequalities, right? When we look at and statements, right, we again said that this is a sentence that indicates that both statements of the compounded sentence are true at the same time. And this tells us when we have our graph, we're looking for the intersection of the two inequalities. Now again, when we write our interval notation, we are looking to write this again from left to the right. So a lot of times, not all the time, but a lot of times, and statements do not use infinity. Okay? For example, if I'm greater than 1 and less than 9, I'd be shaded in here. So when I go to work from left to right, where does this start at on the left? Starts at 1. Where does it end on the right? At 9. Okay, so notice neither side goes to infinity or negative infinity. So it has a starting point and a stopping point. Now when we get to or statements indicates that as long as either statement is true, the entire compound sentence is true. Meaning, this means that we only have to make one of the two inequalities true. Okay? Now, because we don't have an intersection of solutions, right, we say The solution to an OR statement is the union of the two sets. Okay, so let's kind of go ahead and just look at examples here. So right away, when I look at this first one, if I look, I have an open circle on -18 and it's shaded all the way to 6. This would be an AND statement here. And the inequality would be x is greater than -18, less than or equal to 6. So if we look here, this graph on the left starts at -18. Since it's an open circle, it'll be round parentheses. It ends at 6. Since it's a closed dot, it'd be a square bracket. So our interval notation would be round parentheses, -18, and it continues all the way to 6. Since 6 is included, we would use a square bracket. Now again, when you look at that, that's telling me the solutions to the inequality start at -18 and go all the way to 6. Now number 10, if you look here, this graph starts at the left, right? Goes all the way to 9, ends, but then there's this gap here, and it starts again at 13. So this is an OR statement. And when we look at it, the inequality would be x is less than 9 or x is greater than or equal to 13. With this, the interval notation, where does the x less than 9 start at on the left? Starts at -infinity, and it goes all the way to 9. The x is greater than or equal to 13 starts at 13 and goes all the way to positive infinity. So what happens here is, how do we represent the gap then? Well, when we write our interval notation, we start at -infinity. It stops at 9. Since it's an open dot on 9, we're going to use a round parentheses. But to connect these two solutions, right, we would put a union, and then it would be square bracket 13, and then it goes to positive infinity. So anytime we have an OR statement, we connect them with the union. So number 11, again, number 11 is a OR statement. Oh, it's actually the same one. So from -infinity to 9, right? That'd be the first part. Unioned with square bracket 13 to infinity. Now, if we had to write the interval notation for the inequality, again, I would sketch the graph. That's the easiest thing to do. Sketch a graph and write it from there. So this first one, number 12, that's an AND statement. It's going to be an open circle on -3. It's going to be an open circle on 9. And we know we would shade in the middle. So when we write the interval notation, where does this graph start on the left? At -3. Since it's an open circle, it's a round parentheses. It ends at 9. Since 9 is not included, or it's an open dot, we know it would be a round bracket. Okay? Number 13, another AND statement. Since it's x is greater than or equal to -4, it'd be a closed dot on -4. Be an open dot on 5. So we're greater than -4, less than 5, so we know it's shaded in the middle. In interval notation, starts at -4 on the left and goes to +5 on the right. It's a square bracket on -4 because it's a closed dot, and it's an open dot on 5, so it's a round parentheses. Now, although number 14 looks like an OR statement, they're connected by AND. And if I go ahead and graph this, x is greater than 0, I know it would be an open dot, graph to the right. X is less than 6 would be an open dot, graph to the left. Where do these intersect? In the middle here. So, since it starts at 0 on the left, it's round parentheses 0, because it's an open dot. It ends at 6, and since it's an open dot, round parenthesis. Now, number 15, this is a tough one, right? This doesn't happen often, but it can. So I know right away when I graph this first one, x is less than negative 3. So if I look, x is less than negative 3 starts there. And if I go ahead and graph this, I know it's going to be shaded to the left. When I look at the next one, x is less than or equal to 8, close dot on 8, and I know I would shade to the left, and this shading goes on forever and ever and ever. I use these two colors for a reason because, notice, if it's an and statement, it's the intersection of the two graphs. So where do these colors start to intersect? They start to intersect at 3. So the true solution to this would be x is less than negative 3. So when we write the interval notation, we would start at negative infinity and it would end at 3. So it would be negative infinity to 3. We do not include 3 include negative 3 because it does not make the first inequality true. That's a tough problem. Number 16, we have x is, this is an or statement now. So x is greater than 3. So we know open circle on 3, shade right. X is less than negative 3. Open circle on negative 3, shade left. This is an or statement. So if I write an interval notation for the left side, it starts at negative infinity, ends at negative 3. Then because we don't include the middle values, we know we have a union. And the right side starts at 3. It's an open circle on 3, so it's 3. And it goes all the way to positive infinity. Okay? Now the last, number 17 here. X is less than or equal to 5. So we know close dot on 5 and a shade left. Greater than 10, open circle on 10, shade to the right. So right away we know this left side starts at negative infinity, ends at 5. So negative infinity, 5, square bracket. It's an or statement, so we have a union. Starts at 10 and goes to positive infinity. So round bracket 10, it's a round bracket because it's open and it goes to infinity, round. Now, these last few are interesting. We're going to take the interval notation and we're going to graph them and then write the inequality. So the first one starts at negative infinity and ends at 8. And since it's a square bracket, we know it's a closed dot on 8 and it goes from negative infinity to 8. So the inequality here is basically x is less than or equal to 8. The next one, it's a round bracket on negative 7. And it goes all the way to positive infinity. So we know all my x values are to the right of negative 7, so greater than negative 7. Number 20, closed dot on negative 5. And this goes all the way to positive 12, and it's an open circle on positive 12. So it's all of these values, right? That's an and statement with x in the middle. And x is greater than or equal to negative 5 and less than 12. And the last one here starts at negative infinity, goes all the way to 0, has a closed dot on 0. It's unioned with starting back up at 8 with a closed dot. I know it's a closed dot on these because if this is a bracket, it's a closed dot. Closed dot on 8 and goes to infinity. So the inequality here would be x is less than or equal to 0 or x is greater than or equal to 8. And we are done. Go ahead, do the student practice and let us know if you have questions.